But then, you know, you always get into difficulties when you try to explain the behavior of permanent magnets. Let me show you what I mean. I'm going to use 2 bar magnets, and first of all, I place them with like poles opposite. So, of course, they repel each other. If I put a bit of steel now on the pole of that magnet, I don't change the polarity of it by just doing that. If that was a north pole before, then the outside of the steel will still be a north pole, and so it should still repel the other magnet. Shouldn't it? Surprise, surprise. Now, in that condition, both magnets are pulling on the steel outwards. They're trying to split it in half. Let's give them the opportunity to do that by making it a double piece of steel. Now, when I release my fingers, will they in fact succeed in pulling it in half? They do. Now, here's a situation, isn't it? In that condition, they just don't want to know each other. But with only a single piece of steel, both magnets are quite happy to attach themselves to it. I told you permanent magnets were going to be difficult, but believe me, there's worse to follow. Suppose I take an unmagnetized steel ball and an unmagnetized bit of steel. I'm going to put the steel ball on the magnet pole. As I approach it and touch it with the unmagnetized bit, I can always succeed in bringing the ball away with the unmagnetized piece. If I put a bit of cardboard in between magnet and ball to begin with, you can actually see the ball jump away from the magnet. Now, I'm going to suggest that an explanation of these phenomena using the pole concept would be very difficult indeed.